Okay. Balloon Geometries by Nicole Jones. All right, so the first linear arrangement, or the first one that we're going to talk about is the linear, and that one has an arrangement of two electron domains. So here's the two, and then a central domain, and there is an 80-degree angle here. So the type of molecule is AX2EO. So that means the A is the central, the X are the two attachments, and the E is how many lone pairs. So this can have 0 lone pairs. It's a very happy little guy. All right, so that's the linear, and an example of that is carbon dioxide. The next one is the trigonal planar, and that has an arrangement of 3 electron domains. So that is this guy here. So he has 3 electron domains. So there's 3 outer atoms at the corners of an equilateral triangle. So here's the center one, and here's the equal triangles. So they have a 120-degree angle. That's the distance between them. It's 120 degrees. This can have 1 lone pair. When it has 1 lone pair, it's the bent, and that's kind of like hydrogen dioxide. So that would be an AB2E. So it would have 2 attachments, and then the central, and then this one would be a lone pair here, and that pushes these together because the electrical pushiness of it all. All right. Oh, an example of that is boron trifluoride BF3. All right. The next one is the tetrahedral, and that is a 4. And this one has 4 electron domains. And this one I thought was like this, but it's not, because that would be like, I don't know what the geometry of that is, but it is, they're 109, so they're kind of all, this one's up here and these kind of push down on it, so it's kind of standing up like it's got 3 legs, and this one's kind of up there. And so that's this one. It has 4 domain attachments, and so, but it can be an AB3E, which is which is with 1 lone pair, and then it can have AB2E, which is where it can have 2 lone pair. And an example of that is PO4 or PO4 -3 ion. So there's that one. That's the tetrahedral. All right, and then the next one, I didn't have enough balloons to make one of each, so I kind of got to improvise here. So the next one is the trigonal bipyramidal, and this one has 5. So there's the 3. We kind of take that triangular one, and then we stick one on top. So these will have the 120 degrees, but these ones will stick on top and bottom at 90 degrees. So boom and boom. Can you see it? I think you can see it. So one on the top, one on the bottom. These will be 90 degrees to each other. This one, and that's 5 electron domains. And this one can be AB4E, which has 1 lone pair, AB3E2, which will have 3, and then I'll have 2 lone pair, and then the AB2E3, which will have 3 lone pair. An example of this one is BCl5, phosphorus pentachloride. So there's that one. That's 5. Oh, and then our last one is octahedral. And this one is very symmetrical. This has 6 electron domains. And so these are all 90 degrees. So 90 degrees, 90 degrees, everything's 90 degrees. This one can have one lone pair, and then it can also be AB4E, where it has just two, and then it has two lone pair. And an example of that is tungsten hexachloride. And I think that's everything. Number of domains, type of molecule, electron domain geometry, and the balloons, and the number of lone pairs, and an example. All right, I think that's everything. And here is my source. This was an awesome chart that gave me all that information and helped me make sense of it all. Okay, all right, thanks.